All right, at the equivalence point, we have to think about what's happening in our titration. So again, we have our NaOH in our burette and our acetic acid in our Erlenmeyer flask. We're adding both, and it's making NaCHOO, so sodium acetate and water. So if this is what's in our Erlenmeyer flask, at equivalence, we're completely consuming both of our reactants. So all that's left over now is this in our Erlenmeyer flask. And we have to think about how does each of these substances, as their ions, affect our pH. Water has a pH of 7. This comes from the strong base, so it's going to have a pH of 7. This comes from a weak acid. It's going to affect the pH. So I need to figure out what is this going to do to my pH. So the first thing that we're going to do is, number 1, figure out the moles of our acid. We have calculated this before in this question, but we're going to take the milliliters, multiply it by the concentration to get our mole. Because my moles of my acid are equal to my moles of my base, I'm going to show that step here to find my moles of my base. Moles base in step 1. Now that I have the moles of both my acid and my base, I need to figure out how many milliliters of my base did I need to get to this amount of moles. So I take my molar amount, my moles, and I divide by my concentration to get how many liters. So this is 50 milliliters that I needed to get to this amount of moles of my base to reach my equivalence. Now, I'm going to take the moles of my conjugate base. So this comes from the moles of my base, just like in the previous question. So this amount of moles divided by my total volume, I get a new concentration of my acetate ion. And this is all that I'm concerned with, because in my solution, again, I only have sodium, water, and acetate. This is the only one that matters when I'm calculating my pH. So I put in my initial concentration. There's a change. Now, in order to calculate the approximation method, I need to know that I don't have an acid anymore. I have a conjugate base. So I need to take the Kb value, and I have to take my initial concentration. So 5 times 10 to the negative 2 divided by my Kb, I do reach my approximation method. Now there's a change. At equilibrium, this is my amount. I have a remake of acetic acid, and I'm producing hydroxide ions. So this is what I'm going to use to eventually find my pH. I put this into my equilibrium expression and I solve for x. I get a POH, and then I use my equation. pH is equal to 14 minus 5.28 to get to this number. So we're going to be using a little bit of salt knowledge to solve questions at equivalence. After we add 60 milliliters of our base, we're going to reconsider now what's happening in our titration. I know this is a 1-to-1 ratio. I know that I have 50 milliliters of this, and I have 60 milliliters of this. Because of this difference in volume, I'm going to assume that this is going to be my excess reagent, and I'm going to have a pH that is greater than 7, because this is my limiting reagent and it will be completely consumed. So what will be left over is my base. It's just a prediction based on the volume and the fact that it's a 1-to-1 ratio. But again, we have to do the math. So my first step here, just like in my previous question, in all of the questions, we're going to figure out the limiting reagent, unless it's before the titration, where it's only your weak substance, or at the equivalence where our moles will be equal and there's no limiting reagent. So number one, we need to figure out the moles of both our acid and our base. We identified the limiting reagent. You will have to show your step of the comparison. Then you're going to figure out how much of NaOH is left over by taking the excess, subtracting it by the used amount. This is your moles of NaOH left. Here, this is our new calculation of our concentration because we changed the volume, and we get this molar amount. Now, in the other question, we did have to consider the conjugate being formed. Because this is a strong base, I'm only looking at my concentration of hydroxide ions because it is so much stronger from this base. And we don't have to think about the weak substances, what is being affected. So because I have a strong base, I know that it's going to go 100% to hydroxide ions. I can put in my pOH and solve for my pH. So again, even though I am reforming some substances like I did in my pH before equivalence, because this is such a stronger amount, my pH will depend solely on how much hydroxide I have.